about with high-level roadmap. So,
okay.
Take it on.
So this is very similar to the presentation I'm actually going to give at I/O, with the exception that because we're kind of all adults in the room, I decided to actually add some criticisms of GWT in there that are my personal opinion, but some of them are probably shared by the rest of the team. Some of them people might disagree with. First, First, let's talk a little bit about GWT's history. If you didn't see my presentation last year on the history of GWT, this is basically it. Originally released in 2006. Kind of amazing to think about it, but it's like 7 years old now, and it's undergone a lot of revisions. I basically pick out like 3 things on that list that were major. GWT 1.5, I think, was major because we added generic support. That was a big overhaul. We also added overlay types. That was a pretty big addition. Then GWT 2.0 was like a giant release. A totally giant set of new features. You know, you had out-of-process hosted mode, thanks to John Tamplin. You had draft compile, UI binder, layout panels, code splitters, client bundles, CSS resources. More on that list I'm not even thinking about. And then pretty much everything from like 2.1 to 2.5 was like minor integrations. Except for 2.5, we added super dev mode, which I think was a big thing. There's some other things we did that were experimental, but not very important. So the main thing I want to get to, though, is like GWT has undergone a lot of evolution over the years, but it's also picked up a lot of technical debt, I think, that's kind of sabotaged our agility a little bit. And some of that is from the way the code base is, and some of it's basically the process of the project and how it's evolved over the years. These are some of my personal opinions of what are some of the pain points or decisions that, in hindsight, we might have done differently if we had foreknowledge. We basically made a early on decision to place a disproportionate emphasis on code size. And before someone had built an application like AdWords, this was not a bad decision because back in GWT 1.3, 1.4, 1.5, a compile would take like a minute. It wasn't too bad, 2 minutes, 3 minutes. You could stomach that. Now, like our biggest applications using like our mega build, internal build systems take on the order of 10 minutes, and it's a little getting a little long in the tooth. And so we probably should have over the years started to focus more on tweaking the compiler internally to speed up the actual compilation. But we didn't because we had an answer for it. We would basically say use dev mode, and I think that was a legitimate answer for that situation. You're never going to get as fast of a cycle as you would refreshing in dev mode. It's just it's running the code in the JVM. It's not compiling anything, and so that's a perfectly legitimate argument, except for the fact that people also like to run integration tests on every commit, and they have pre-submit queues. So, while you're refreshing and you're developing, your build cycle is very fast, but then you go to check it in, and you're waiting like a couple hours, for all the tests to compile and run through. Like, for example, there internally at Google, some of our big apps, people will be blocked for hours waiting for their tests to go through, And we can distribute the test. You got to think about Google, right? We're farming those tests out to a farm, and it's still taking like a hell of a long time. And so the compiler has gotten like, I don't know if it's gotten slower over the years. It's more like we've accumulated more and more code that has to be compiled, and the compiler hasn't kept up. The other thing is that when the Atlanta office was closed, we lost a lot of people, a lot of good people. And when it came down to a much smaller GWT team to manage the GWT project and to basically support people who are using it, we had to start looking at things that we didn't personally write and find bugs in them, like, for example, GWT RPC or UI binder. And it kind of to me personally, I kind of saw the fact that the internal code base of GWT is massively complex. Sometimes it's overly complex in certain areas for what people want to get done. GWT RPC is marvelous in its simplicity. It's really easy to get up and running, but that
simplicity. That's if you don't look at the internals.
That's if you don't look at the internals, and also it's like a ballooning mortgage where the upfront cost is really cheap, but then later, if you're not careful, you're finding yourself having massive amounts of code bloat in your generated JavaScript because it's like serializing lots of types that you didn't even want because you happen to drop a jar file in your dependency path and you didn't realize everything in there implements serializable, and you had returned to object from an RPC method, and so just serializing Java objects as is to implement serializable. It's easy, but later you pay a cost, right? The other thing is that the system that implements all of these things, like UI binder and RPC, is based off of GWT generators. And GWT generators made a decision early on that they're just going to hand the entire world to the generator. So the generator basically sees everything that's in your module path, all of the classes. Not just your module, everything on the class path. And some generators actually will query everything. They'll say, give me every type that you can see, and I'm going to basically check every one of them for potentially having to generate something based on that type. And it simplifies the build system a lot because now Maven or Ant or they don't have to know anything about GWT generators. You just invoke the GWT compiler, or your IDE knows how to invoke the GWT compiler, and you don't have to pay any kind of expensive integrations with your build tools, your IDEs to make GWT work. And I think that was like a key part of the decision early on, was basically we didn't want to be in the business of having to maintain like a GPE plugin or an IntelliJ plugin to make GWT work. And so having GWT.create be so magical like that actually had a rational basis. But because it sees everything, the GWT.create generators overprocess. They end up having to look at more dependencies than they really should. They're not really scoped down. And so that means, like, if you change code somewhere in your project that's not even related to something that's a generator needs to look at, it still might decide to regenerate based on something that's changed that has no relevancy, just because it's looking at everything. And it also kind of doesn't work with the IDE environment the way I think it should. You don't see the code that's generated most of the time. So with like pre-generation, in a lot of other environments, people would run some code to generate the code outside of the compile process, as input to the compiler, and actually you would see it on disk. You'd see it as an artifact. You'd be able to look at it. And GWT.create tends to hide stuff. Also, if you look, when the GWT.create was created, we didn't have Juice, we didn't have Dagger, we didn't have apt processing, and the world's kind of changed since then. I mean, Mike Brock's going to do a presentation later on CDI and GWT, and you'll see that it's remarkably simpler than the way GWT.create works. And so, maybe there's a better way. Also, the widget system was very heavyweight, and there's a reason why it was built like that, which is because we had to make it work with IE6, and so. Especially with IE6's memory leak, that's just all over the place. And so, creating and instantiating lots of widgets and putting them into a nested hierarchy is like super expensive. And UI binder was, kind of a way to fix that, which is basically where most of your layout and most of the content of your page would basically be like a pre-built string, and then that would be like injected into some of your widgets, and some of the pieces of it would be widgets. But when we look at UI binder and try to think about maintaining it, it's a massive code base, and it's like super complex for in like some other web development languages, which is a very simple thing, which is templating, right? And so and also XML is just kind of out of fashion now. Like XHTML, when they started it, XHTML looked like it maybe was going to be like replace HTML. Now it's basically dead in the water. So I'm not so sure that if we had to redo everything over, I think maybe going with just like an HTML just pure HTML and having some extra attributes or something in it would have been better than trying to enforce XHTML. With RPC, another thing we did early on is originally objects had to implement is serializable in order to be considered a candidate for serialization. And I think that was actually the right decision. But there was such an outcry from people who were using it, was saying, look, I've got all these objects, they already implement serializable. Can't you just make serializable work like is serializable? And the GWT team basically kind of caved in on that, and they support serializable. But the fallout from that is like I said, when RPC is trying to figure out like the return value of a method, like what possibly objects could be deserialized, could be sent from the server to the client. Now it doesn't just see like maybe 2 or 3 classes that are marked as serializable. It sees like hundreds or thousands, right? And if you're not careful in terms of how you define your RPC interfaces, you can just end up with like a giant list of potential objects that can be sent from the server to the client, even though in reality 99% of them will never be instantiated and sent to the client. And so I think that was probably another sort of bad decision that imposed a massive cost on us later. I kind of feel like we should have cooperated with the Clojure team early on with respect to the JavaScript compiler. We ended up building our own JavaScript AST with our own set of optimizations, duplicating some of what they did. And a lot of what they actually do is stuff that we just decided never to do, but actually is very valuable. It's all of these peephole optimizations, like turning true into bang 0, or turning 10,000 into 1E3. Those are 1E4. Those seem like trivialities, like maybe they shave off 0.1% in code size, but they've got like dozens and dozens of them. They got like 50, and it turns out a lot of the Clojure peephole optimizations reduce code size in a non-trivial way, like 5% or more. Moreover, their inliner is a lot better than our JS inliner. So like we could have kind of had better optimizations and saved some work. We kind of stole some of their code early on. The next one's kind of, I think, controversial. Different people have different opinions. Some people want GWT to be a generic toolkit that just makes no opinion about how things look or how how the server should look. But that actually had impact on some of the ways things are implemented in GWT. For example, the code splitter only has what's called a single leftovers fragment. And part of the reason why it doesn't actually have a tree of leftovers fragments is because to actually implement that properly, you'd need a server-side servlet serving up the JS to concatenate it on the fly based on the order in which the split point is hit in your program. And Lex Spoon, who developed the system early on, he kind of made the decision that we want GWT apps to basically be hosted like static files anywhere. You just drop the list of compiled files on like a CDN, and it should just work. And I think that's a valuable goal to have, but I also think we could have gotten a lot more mileage if we actually had said, there's an official GWT servlet that you extend, and basically it does things for you, like serve up the JS for you more efficiently, set the headers for you automatically, so you don't have to like worry about no cache versus cache. Stuff that would help the developer out. In fact, we have such a servlet internally. It's called GWT Resource Servlet. So we just never released it to the outside world.
Why not? It runs on GSE, not engineering.
Yeah, like every GWT project internally I know uses the GWT Resource Servlet. Bad out-of-the-box UI is another controversial thing. Should we actually have any kind of widgets that look nice that have like some professional design applied to them out of the box? Some people would say no. A lot of web designers actually wouldn't like that because they actually prefer to like totally customize the way things look, and they don't want their app to look like every other app. They want it to look unique. On the other hand, I know a lot of developers who were frustrated with GWT early on, up until we started adding the themes, where they look at the code, they read the tutorials, they develop like an app, and out of the box it looks horrible. They kind of expected an experience that would be like developing Swing or C# because we've got this desktop-like widget system. but then they build a UI using the widgets, and it comes out just looking nasty. And so, even if people decided they didn't want to use it, I think early on maybe we could have invested some money, got like an artist or an official designer. Not that like the ones in Atlanta weren't good, but we didn't do that till late. Like the first couple of versions looked pretty nasty. Only around GWT 2.0 did I think it started to look nice, like with the sub widgets and stuff. Also, the couple other things. The SDK is just a monolithic Uber jar that has inside of it like tons and tons and tons of other jars that have been rebased. We've got spaghetti-coded cyclical dependencies, which Thomas Breuer is basically trying to untangle so that we can have a more modularized build. And you almost can't avoid pulling in all of user.gwt.xml. If you actually try to develop an app and you try to consume any other piece of GWT outside of core, you almost invariably will hit an inherits clause somewhere that takes you back to user.gwt.xml, and then you end up importing every module in the whole SDK. And I think this actually kind of inhibits, first of all, it affects build time, because you're pulling in everything. So the compiler now, basically the resource oracles in the compiler, which we'll talk about tomorrow, end up seeing all of the source in GWT user, not a subset of it. The second thing is that if you wanted to maintain a particular library or contribute to a particular piece of GWT, let's say you wanted to work with the editor framework, or you wanted to work with John on I18N, you just can't just rebuild and only run the test on I18N. You end up having to rebuild everything, and so it makes it hard for people to just have like a small area of the SDK, small service area to work with. They actually have to end up rebuilding the whole thing every time, and so I think that's kind of a problem. Finally, I said this last year, but GWT started out as an open source project. It lived in Subversion first, and then eventually, kind of even without the community noticing, we inverted the relationship. So it used to be that the source of truth was an SVN, and we'd import the code on like a weekly basis into our internal repositories for our internal users. But that was before GWT really became a big success internally. Once people started using it internally, paradoxically, the success of GWT internally caused us to kind of slow down our external efforts, right? So now the internal bugs became the priority. The internal repository became the priority. And so basically, once Google became the source of truth for GWT, it became a lot harder for anyone else to contribute a patch. It's not like you couldn't get a patch in, but really you were at like the end of the line. If the AdWords team had a queue of bugs on us, we're not going to look at your patch, in a timely fashion, because we'd have to commit it for you now, because the source of truth is in Google, and we just can't let anybody commit, because you commit a bug that breaks AdWords, we make 97% of our revenue from that. We can't take that chance. So that.
Well, even when SVN was source of truth, there were no external committers.
That's true. I think I was given the external commit access at one time.
I don't think so, but still, when you imported it to internally, you had to run all the tests, and that was the headache.
So, I mean, basically, this is sort of my bitch fest about what I think. Some of the things that I perceive as painful that we might have made different decisions in hindsight. The question is, can we fix any of this stuff? Should we fix it? Do you agree with me on any of those points? And can we do it preserving backwards compatibility? So I'm not going to say let's take away GoToRPC, let's take away UI binder, and deprecate those things. I think that ship has sailed. We can't do that. Too many people using them, and there are legitimate reasons. Some of those things actually are nice to use in certain contexts. Like I don't have a problem using GWT-RPC. I think to get up and running really fast, it's for certain projects actually it is pretty nice. But going forward, maybe we need some things that are like simpler and easier to maintain. And can we escape some of the technical debt we've built up?
One question.
Yeah.
So you are saying while we are preserving backwards compatibility. Is this actually a limitation? Should we actually try to preserve the backwards compatibility for all of this stuff?
I think in most cases probably we have to, but we might be able to do it in a way that, like, for example, if UI binder, it becomes like a separate library in the far future, right? So you can either use it or not, just add it to your dependency if you want to use it, right? So it would just be another separate module versus like every time we release in that version of the SDK, we have to we have to keep it in lockstep with the SDK.
Like for example, you could have a generator API that doesn't have whole world exposed to the generators, and new generators use that. And if you need GWT RPC, then you wind up using the old API, which pulls in everything.
Yeah, exactly. We kind of tried to do, like, we started introducing incremental generators, and we ported like maybe one or two things to it, like client bundle. I don't know if ITN uses it or not, but we never really fully doubled down on that. Do you have a question, or did you?
No, I was just stretching.
Oh.
My back
Okay.
hurts. I slept on a.
So the question is, can we fix this? I think we can, and I think you guys can help. I think part of the reason to have this meetup is to try to re-energize the external contributor community to help fix some of these problems. And that's basically what the rest of my presentation is about, the future. So I divided this up into a series of steps. And some of the steps we've already taken and we've already completed. So step one basically was sort of to de-Googleize GWT somewhat, right? And so we formed the GWT steering committee to give other people a chance basically to take some ownership in GWT's future. That's done. We moved to a new version control system, Git on gwt.googlesource.com. That's done. We have a new code review system. If you've ever used the old one, Right-Velt, you know how agonizingly slow it can be.
I don't know that Garrett's faster, actually.
Garrett's a little bit faster, you know.
Garrett just eats up my comments.
But I like Garrett better than Right-Velt, so it's an improvement. Allow external contributors direct commit access. Matt, I think that's done, right? Where is Matt? Or near done, almost done, right?
Yeah, we just
Steering committee members. Yeah, very close to being done. External build bot, we have one of those now. So eventually the idea is that if you're contributing and you land a patch, the build bot will make a nightly build, push out another jar, and then basically building off of head becomes a lot easier. It becomes more like Google internally, where basically you can just have your app always depend on head if you want to, which is what we do internally. Update the website and make it community owned. So I mean, the old website was sort of community owned, like the wiki could be, in theory, could be edited by other people. But the new site that Daniel's working on literally is in Git, and so you can actually edit it yourself. The old website on code.google.com or developers.google.com actually used like an internal proprietary like HTML templating format that we use for documentation, and so it just could not be edited by anybody externally. The new one uses Markdown.
And it was painful internally.
Oh, yeah, I don't even want to. When GWT 2.5 came out, and for the first time I actually had to write like some documentation for that thing, it was not pretty. Modularized builds, and so like it would be nice if if you were building Request Factory or if you're rebuilding I18N or one of these other pieces, you can just build that part and just run tests on that part when you're iterating. I mean, ultimately you have to run an integration test to rebuild everything, but it sucks, like for example with GWT, to run ant-disdev every single time you make a change, right, and regenerate all of the jars out of it. It just takes too long. I already discussed nightly snapshots. So basically, to make it easier for you guys to participate in defining the feature set that will be in the future of GWT, as well as to contribute patches really easy that can then make it into the build artifacts that you can then consume immediately. Just kind of closing the entire loop and making it faster and easier and more agile. The second step, which we did with the steering committee, was to draw up a set of principles and areas of focus, right? Which is, these are very abstract, but what are the core philosophical things that we want to do with GWT going forward? And so these are basically the list that we came up with. And so, like, for example, the first one is openness and simplicity, which is to, Quit's always been an open project. It's always been open source, but we want to make it even more open to people and more and simpler to basically contribute to it. We want to continue to double down on speed. That really always has been a core thing of Quit. Well, not the compiler speed per se, but for example, making code size as small as possible, optimizing round trip latency, and those things have been core to Quit, and so we're going to keep doing that. Interoperability. Quit early on had a pretty good interoperable system for dealing with JavaScript. Like, for example, if you just take Dart as an example, they did not start out with that, and basically like a year later they find they actually have to go back and do that because the real world is a polyglot world. You have a bunch of different people go out and they consume and cobble together different parts of technology. They grab JS libraries, they grab Java libraries, and if you don't make it easy for people to glue things together, they end up choosing something else, and so or they lose productivity. So we want to make things more interoperable with JavaScript, but we also want to make things more interoperable with Java. For example, supporting Java 7 and keeping keeping up with the latest JDKs. More emulation libraries where they make sense. Now, we always get requests to add things to the Quit emulation library that seem like they would be a great idea in terms of developer productivity, but we don't do them because they actually would impose way too high of a cost. For example, fully supporting Java line reflection, supporting calendar, supporting like Java text, time zones, and things like that. Like, for example, if you were to try to implement like the Java calendar or the Java notion of time zones, you're going to pull in like 400 and something, probably more. You probably know the exact number. Like a massive database of locale specific information, and that's just going to immediately blow your app up with one line of code. So,
and since all the APIs are synchronous, you can't move that off to a server.
Yeah. So it's there are some things where we just can't do them just for practical reasons, but for other things, it does make sense. For example, when we built the Quake demo, we actually built out Java I/O file system, and so on, because it just so happens the modern browsers actually have this synchronous file system API in them now. So you literally can like read and write files now. And they also have typed arrays, so Java and I/O, we built that out. So there's some things actually that you could build out, and if you choose not to consume them, they don't add anything. And if you choose to consume them, actually the impact is not that large. And the code, the actual implementation complexity is relatively small too. Mobility. The world has changed a lot since Quit 1.0. There's been a lot of talk recently for like a number of key apps. Mobile usage has now eclipsed desktop usage. So like across the industry, people are seeing that they actually really need to go with a mobile-first strategy because like there are a lot of people just doing stuff from their phone by default first. Quit has, and Daniel is going to talk a lot about this at I/O. Quit has a lot of the underlying fundamentals to support a good mobile experience. Like we have stuff for reducing HTTP requests, client bundle. We can produce, monolithic, perfectly cacheable files that can be, packaged and installed. There's a lot of stuff that Quit does already out of the box and has done for years that could make a good system for building mobile apps.
There's actually one thing that's quite unique to Quit, is actually running your CSS as well.
Yeah, well, because Quit sees the whole world of resources, so it can do things beyond just optimized code. The key thing though is that we don't really have any attention paid to actually optimizing the UI for mobile. And on mobile devices, the UI is critical. I mean, a large part of why the mobile web is kind of under assault by native is because of jankiness issues. It's just really hard to build a UI in HTML and CSS on a mobile device that avoids pathological hazards with like the GPU compositor. And so if you don't know like what you're doing and you just like go to w3schools.com and you hack up like a HTML and a CSS page, more than likely you're causing excessive layouts, excessive repaints, you're not leveraging the compositor. You really have to kind of know what you're doing. And so it kind of behooves us to gather together the world's like foremost experts on like making kick-ass mobile widgets and burn that knowledge into or bake it into the core like widgets that come out of the box for mobile.
So the interesting thing there is we did that before for IE6, so I wonder how much are the underlying technologies going to change on mobile? Because it seems like it might be a moving target.
It might, in some cases, it might be that this is just a bridge, in that as the browsers get better on the mobile devices, maybe they don't have as many pathological hazards. Like right now, you have to heavily hint mobile web stuff. You have to specifically tell the browser, like, this particular div tag, I want this thing to be rendered once, cached from the GPU, it's like an image, and then composited. And the way people do that now is with a hack. They add like a CSS 3D transform to it. That's the identity transform. Like transform, nothing. Or scale, set scale to be 1.0. And these hacks basically act like you're about to use a CSS3 animation, so the browser goes, oh, you're going to do CSS3 animation, so I'm going to put this thing on the GPU and cache the image. So it's more efficient to like move it around, but actually you're not doing any animations. But it actually makes that when you go to scroll later, or you flick, that actually things are smooth. But like, so it's possible that the browser could get more intelligent and automatically know how to do that. But we probably do have to build in some things to actually do it in the meantime. Reliability has been another sort of thorn in our side. For example, GWT unit test cases are often flaky. Especially in some browsers like IE, they fail them for mysterious reasons. You run them again, they succeed. There's a lot of timing dependencies in some of them. Something takes slightly longer to compile or slightly longer to run. The test fails for mysterious reasons. GWT unit test cases are kind of laborious to write, and they take too long to compile sometimes. If you're like doing it in web mode. So those things kind of inhibit people's natural reaction to actually writing them, because every kind of irritation you have where you write this unit test, you want to run it, it's just really irritating to run it, it's hard to actually interactively run it, and then it basically flakes out on you, right? And so you basically say, screw it, I'm not going to write that unit test. Maybe I'll just like use Selenium for the entire app or something like that. So,
well, the other thing is people invent entire architectures to run in JUnit. So
yeah, and so part of the thing is to work around this. People actually have come up with an enormous number of workarounds to run pure JRE tests. For example, at Google, we have something called, the Java GWT test case, where people have mocked out almost the entire GWT user library with like basically JRE, like DOM elements and stuff that don't do anything to, and then they're able to run like gwt.create will just run and then return like a mock version for a lot of stuff. And so they mock out the entire browser, and then the unit test basically runs like really fast. But I would argue actually that running with a mocked-out browser is not a very good test, because often the browsers themselves have quirks that you actually really do need to test.
Depends on what you're testing.
Yeah. So there's also a lot of bugs that have accumulated in Issue Tracker over the years that we just haven't got to. And so part of doubling down on reliability is basically getting people to submit, and making it easy for them to do, getting people to submit fixes for all of these things. There's probably like 100 bugs on the Issue Tracker in the top 100 that are probably critical and probably haven't been fixed, and no one's gotten around to them, but probably vastly improve the reliability and actually stop people from what they do today, I think, is that they overlay their own patches onto GWT, but they never contribute them back. So there's people downloading GWT, they have their own Google GWT user, patches, and then basically they never make it back, and so no one else can benefit from them. And finally, embeddability. The fact that GWT is basically a monolithic SDK with like a few entry points has kind of made it hard for people who are building tools to actually reuse parts of it. Like if you wanted to build, let's say, a GWT static analysis tool that basically didn't compile anything, but maybe you wanted to leverage the existing Java AST to perform, let's say, security analysis or to check some other things, some other best practices or something. It's really hard today to basically say, let me import the compiler and feed it this class path, and it will give me back an AST, and I can write some checks to write, like, let's say, a static analysis tool. Someone else might have an IDE. Red Hat is building some stuff where they'd like to actually do some AST manipulations, but they're not writing optimization passes. They just want to reuse the AST for code analysis, and might talk about that later. And it's just, we don't have any hook points for those things. We make it hard to kind of split up and reuse pieces of GWT in other scenarios. And I mean, there's valid reasons for arguing that that's actually a good thing to do, because if we make those APIs public, that means we have to support them going forward. It means we can't change them. But there's probably a middle ground. We can probably, find some points of granularity where, other than, running the main method of compiler.java, there's probably some leeway in between where we can make the pieces more reusable and embeddable. So step 3 basically is to flesh out the plan and find owners. It's easy for me to stand up here and present a roadmap to everybody, and everyone will agree to it. No one will object. They'll say, "Oh, cool, more mobile widgets. That's awesome, right? Faster compiler. That's awesome. When's it coming? Ship it. Yes." But part of the reason for me presenting this is to say that we need your help on some of this. And so, if you see something that looks really interesting to you, and you'd like to help with it, or you'd like to see it sooner. Don't just assume that Google has like an army of like 30 people that's going to rush to implement these things. Really, this is about engaging with the community to have you guys actually help us complete this vision. Let's look at the roadmap. Let's discuss what things are of interest to various people, if anything is of interest to you guys, and then let's get to work and contributing some patches or filing some bugs at least. And so the rest of the presentation is basically what I'm going to show at I/O, and I don't really know if I need to go over this again. There is some specifics in here that I didn't talk about, like, what do we mean by improving speed? We'd like to at least double the compile time. It goes not double compile. We'd like to double the speed of double the compile time is easy. -X enable closure compiler. There you go. You're done. Right. What we'd like to do is we'd like to double the speed of the compiler. We'd like to improve the speed of the super dev mode refresh so that it becomes more of a viable replacement to dev mode. It's probably, for really, really giant apps, like something like AdWords, it's going to be hard. It's going to be hard to actually have it work for that. But for smaller apps, we could improve it to the point where it could be a reasonable replacement. You could choose it as an alternative. We're going to improve the code size. There are some plans to radically improve the code splitter. Now, the code splitter, if you guys have ever used it over the years, using it correctly is kind of like a black art, because it's very, very easy, if you're not careful and you have very, very many split points, to have the leftovers fragment balloon up. The leftover fragment is basically any code that's shared by two exclusive split points. And so if you're not constantly running story over compile and constantly looking where dependencies are coming from, it's really hard to optimize that leftovers fragment. And that leftovers fragment is downloaded before any of your split points are run. And so you think you're getting a huge gain because you're shrinking your initial fragment, but then the first time you hit any bit of functionality, it has to load up a split point. You have to wait for this giant file to load in. And so there has been some recent improvements with that with the fragment merger. But Roberto has some ideas about significantly improving the way the code splitter works, almost to the point where it would be like a no-brainer. You could just go hog wild with split points, and the compiler would do the right thing. Even if you created a bunch of tiny split points, the compiler would merge them together. You say things like, make them at least 50K big, because if they're too small, I don't want to waste the HTTP request on them. Make them no bigger than 200K, and the compiler will properly coalesce them and ensure that everything is optimal. One of the things I've heard from some teams at Google is that the GWT output is suboptimal for V8. V8 has this thing called hidden classes, where it basically tries to predict a vtable for an object by looking at what is assigned to in a constructor. And so, you know, if you have a class and you assign to fields A, B, and C, V8 will look at that and say, hey, there's this class, and it seems to have 3 fields. One's name's A, one name's B, one name's C. I'm going to give that thing a type, call it ABC type, and basically I'm going to construct a vtable for it, like you would have in like C++ code. But with Java, you have overloaded constructors. So you could have 3 different constructors, and they can assign to 3 different fields. They could not assign to 2 of the fields, for example. And so when V8 sees one constructor only initializes field A, and the other 2 constructors initialize maybe B and C or A, B, and C, it sees that as 3 different types. And so you go from having like monomorphic dispatch to polymorphic or megamorphic. It basically slows down the performance of V8. And so we basically could look at like tuning GWT more for Firefox and Chrome.
Yeah, so we'd looked at that in the past, and the problem was that improving the performance for V8 was a massive de-optimization on the other browsers.
Yeah, because Firefox had this idea that tracing JITs were basically the best way to go, and V8 team had basically done a traditional method by method like JIT, and Firefox turned out to be wrong, and they basically have kind of backed off from tracing JITs as being. But if you optimize for one, you end up screwing the other. I think that's the main issue.
But I mean, you could certainly move the permutations into the code gen, so it generates different things for different browsers.
Yeah, and we
do that for string buffer now, and that's it.
Yeah, we also did it for IE has these bugs like you can't have more than like 32,767 statements in a block, and so we've got these weird per IE like fix-ups. It actually brings me to another point of technical debt. We've got fix-ups in GWT now that are like going back to Safari 2 and 3 and like specific builds of Safari 5, for example, the coerce and shift thing. There was a bug in like the shift operator of Nitro in like a certain version of Safari, and so we basically built in a compiler pass to fix it. But it's been in there for like 2 years now. I mean, we should have removed that a long time ago.
And I think there's talk on the mailing list about specific browser bugs in new browsers, right?
Yeah.
So, yeah.
Okay.
Bring that up to date.
So I already talked about interoperability. One of the things that I've been working on internally at Google is interop between Java and JavaScript, making it easier to call between the two. Basically by massively improving GWT exporter. So we have a version of GWT exporter internally. I re-imported like a few months ago. I re-imported the latest version and basically added like a bunch of new stuff to it. And so eventually I'm going to push that back out, but not until it settles down. But just to give you an example of what I would mean by that. For example, you can point, like today if you want to use some JavaScript from Java, you tend to write like an overlay type for it. You write a wrapper method for each and every method that's in the JavaScript. And that's fairly tedious. But it turns out that if the library is well documented, you can actually code gen that overlay type. So for example, at Google we have an internal bit of code that can do that for any closure documented library. So if you have JSDoc on the function, and it says like method 1's a string and a return is like some other JS object, it actually will automatically generate the overlay type. And so it would be nice like if we could take that into the open so that the way you would actually interoperate with external JavaScript is not by writing an overlay type with like hundreds or thousands of JISI methods, but just going into the JavaScript library and adding better documentation to it. So if you actually that would improve things for both sides. It would improve things for the GWT interop, but also would improve the JS library by adding better documentation. I'm almost done. Okay. I'll just skip over. We've talked about that. And so just for mobility's sake, I discussed optimized widgets. The other thing was basically packaging. So app stores are also another thing we have to contend with these days. I personally like drive-by web apps, but distributing things in app stores, is just a reality for today. And so we've got lots of people have built their own set of GWT linkers or their own libraries for doing this. It's been duplicated over and over again. You've done it. I know Matt Mastrozzi has done it with dot spots. There's like umpteen different ones internally. The speed tracer guys have done it for building Chrome extension drafts. We should just like take one of those and have a standard way for Git apps to be packaged as an installable app, a Chrome app or as a phone gap app. So that's basically all I have. There's some speculative stuff that I don't know that probably not worth looking at. The last thing is that when we expect this stuff to happen. We had a discussion in the steering committee, and we basically decided to try to shoot for like a TikTok model. So every 6 months we would have a point release. So like 2.6, maybe by Q4 of December, and then next year at I/O 2014 we'd have Git 3.0. And so minor point releases or fixes would happen like every 6 months, and then the next major release would happen like in 12 months. Of course, there'd always be nightly builds, so you don't have to wait, but a lot of people do. So that's basically all I got for you guys. Any questions?
So we'll break till 11.